This is your video for Accentuate the Negative, Investigation 1.4, Part C, where we're going to continue with integers, but now move on to subtraction. And I'm going to try and combine a couple of things into one video, and that is going to include the 3 learning targets. So the first one that we're going to look at is I am going to go back and demonstrate for you that colored chips still work with the use of subtraction. But since you hopefully have a clear understanding of the chips and how the red and the black are opposites and cancel each other out, I'm going to also push us forward, which is the cause for learning target number 2 and 3, in using an algorithm to solve subtraction, and in that algorithm show how addition and subtraction problems give us the same answer. For this particular lesson, there is no new vocab, but we will be continuing to work on the fact that for this video, black will represent positive and red will represent negative. You may use the colors of your choice. Just make sure that you have a key so you remember which color represents the positive and which color represents the negative. So I'm going to start by going through all these examples, and let me scroll back up here a little bit. Notice that we are going to subtract with integers, and I'm going to mix together now same and different signs. So some of these are both going to be positive, some of these are both going to be negative, and in other examples we'll have one positive and one negative. That is different from when we did addition. But again, hopefully you're a bit more comfortable now, and so we can kind of combine some of these ideas. You can see that your notes are split up. I've got a subtitle of subtraction, and I have a title of addition. And that goes back to that third learning target where it says show how addition and subtraction problems give the same answer. I'm going to start by doing subtraction and then go back and do addition. So what I would like you to do is to draw a line, and you can go approximately down the middle to separate out that you will have subtraction on one side and addition on the other. And I'm going to, like I said, start with subtraction, and I'm going to show you how to use the chip model, first of all, just to show you that it does work. If the chip model does not completely make sense, that is okay. Hopefully then maybe the algorithm or the addition will make sense to you and you can follow that. So that the end goal of this video is that you have one of the methods that I'm showing you that you can continue to work on for classwork. So the first one is a problem that you would typically have seen back in early elementary, 4 minus 3. That is not a difficult problem for you as a 7th grader, but it's good to still be able to model that, where we have 4 positive chips on the board. I have to take away 3 of those, so 1 goes away. That leaves me with, I need 3 to go away, sorry. That leaves me with 1 left over, so my answer is 1. We don't really have to do anything special there because we're not dealing with a mixture of positive or negative numbers, and it's the subtraction we started with as younger students, and the bigger number comes first. But then we move into the second problem, 6 minus 7, where now we have a smaller number first. But 6 is still positive, so we're gonna start with our 6 chips on the board. And this is where we run into a slight problem, because I need to be able to take away 7 black chips. and there are only 6 on the board. And I need to be able to get extra chips on the board without changing the value of the chips that I started with or the chips that I have underlined. Maybe in your mind you've already thought, well, red and black are opposites. Opposites are 0, therefore don't have a mathematical value to them. So where we normally take away sets of opposites, we can add sets of opposites in because it's like adding 0, and 0 doesn't change the value. So because I already have 6 and I know I need to be able to take away 7, I'm only really missing 1 chip. So I'm going to add 1 set of opposites. So it's like having a 6 plus 0, meaning the original board still has 6. Now what that does is it gives me the accurate amount of chips to be able to take away. Because now I have 1, 2, 3, 4, 5, 6, 7 chips. What's left over is still my answer. I have 1 red chip left over, therefore 6 minus 7, the answer is -1. Now be careful and listen to the wording that I am using. You will often hear me say, oh, we need to add something in to make this work. That should trigger a bell in your mind as to why later on we can change this to an addition problem. So keep that thought kind of somewhat at the front of your mind as we go through. All right, we have a -6 minus 4. I need to start with 6 red chips. All right, but I need to be able to take away 4. And 4 is a positive number, so I need to be able to take out 4 black chips. I don't have 4 black chips currently on the board. So I need to somehow add 4 black chips to my board without changing this value. Well, how do we not change a value in math? We need to add 0. So we are going to have to add 4 sets of 0. And in order to get sets of 0, we need to add opposites. All right, now that I have my 4 black chips on here, I haven't changed the actual value of the board. I can take my 4 black chips out. I am now able to subtract those. And I see that I have only red chips left by the time I count those up. -6 minus 4 gives me a total of -10 since I have 10 red chips. Again, I have to add something in to make that work. Let's look at our next one. 5 minus a -8. 5 is positive, so I'm going to start with 5 black chips on the board. I need to be able to take away 8 red chips. There are not currently any on the board, so I need to be able to add in 8 red chips. And I can only add 8 red chips in if I actually add them as pairs of opposites. I'm going to make little dots, that's easier. All right, now I need to be able to take away 8 reds And what am I left over with? Only black chips. And if I were to count them up, I see that even though I'm subtracting here, which would think you might get a smaller number, the chip model shows that I actually increase in value, and I have 13 black chips, or a positive 13. Next one, 4 minus 10. 4 is a positive, so I'm going to start with 4 black chips. I need to be able to take away 10 black chips. Well, I don't have 10 to take away. I do have 4 to take away, which again means I need to add something in. I won't need to add in a full amount of 10. I only need to add in 6 more. But when I add in those 6 more, I also have to add in their opposites, so that I'm not changing again the value. Now I can take away 10. That leaves me with those red chips for a final answer of negative 6. And our last one, we start with negative. We have a negative 2 minus a negative 3. So there's my negative 2. I have to be able to take away 3 red chips because I'm subtracting a negative, but I only have 2. So I'm going to add in 1 additional chip as opposites. Now I'm able to go back and take away the 3 that I need to be able to take away, and you can see what I'm left with. Negative 2 minus a negative 3 actually gives me an answer of positive 1. So again, hopefully you caught on to the fact that I was saying we need to add things in, which is why subtraction and addition have such a close connection to each other. So in this first example, again, this might seem weird because 4 minus 3 is just kind of a natural subtraction problem for us to do. But it still works to have an addition problem that provides for us the same answer. And this is the way that it works. We keep the first number the same. If it wants to write for me. The subtraction will get changed to addition. Now we know that if we were to keep the second number the same, we would get a completely different answer. 4 plus 3 is 7. But we have to get an answer of 1. So the second number, and it's always going to be the second number, this number, the second number, we are going to turn to the opposite. In the original question, it was a positive 3. I am now changing it to a negative 3. We will still get the answer of 1. And you can model that even in the chips, where we have 4 black chips because of positive and 3 red chips because of negative. And by the time you cancel out your opposites, you can see you are still left with 1 black chip, which is the same as when we were left with 1 black chip in the original question. So let's look at the next one. I start with the first number. The subtraction goes to addition. It's the second number that again has to change. It's currently positive, which means I need to change it to its opposite, negative. 6 plus negative 7, or excuse me, 6 plus negative 7 has to give me a negative 1 because the subtraction problem, 6 minus 7, right next to it, gave us a negative 1. We're trying to show how you get the exact same answer. Once again, you could model that with chips. You have your 6 black. I need to add to it 7 red. And by the time you cross off your pairs that cancel each other out, you notice that it's 1 red chip left over. Oh, and look, both examples have 1 red chip left over. So in the next couple, I'm not going to worry about doing the chip model on every single one. Hopefully you can see in the top 2 that addition and subtraction, as long as you convert it appropriately, you will be given the same answer, and the chips represent that answer as well. So let me walk through what I will now refer to as the algorithm going forward. So the original subtraction problem was a -6 minus 4. But again, if you think back to the original one when we did the chips, we had to add something in. So subtraction gets changed to addition, and that second number has to go to its opposite. It was positive, now it's negative. And if you think back to our rules for adding, when you have 2 negatives, you just add like normal and attach the sign. And you can see that our answers match. One of the reasons that we changed subtraction to addition is so that we only ever have to follow one set of rules. So in our next one, we have 5 minus a -8. So here, subtraction goes to addition. The 8 is negative, so now it's going to go positive. I have a problem that we're familiar with since grade school. 5 plus 8, 13. Let's look at the next one. 4 minus 10. Subtraction goes to addition. The 10 is positive, which means it has to go negative. And 4 plus a -10 is a -6. And again, you can follow your rules for addition that we had. All right, last one. -2 minus a -3. Subtraction goes to addition. The second number, the -3, goes to its opposite. It's currently negative, which means it has to go positive. A -2 plus 3 gives me 1. So any subtraction problem can be written as addition. That also means any addition problem can be changed to subtraction. So let's look now at your next page. We're going to go ahead and I want you to pause the video and try the next 3. See if you've got it correct. Go ahead, try starting with the subtraction over here. Do the addition over here. If you can do it without chips, great. If you can't, go ahead and draw your chips back in. I will show you the chip method when you go ahead and press play again. All right, so take a look at how you did. On the addition side, hopefully you can see the difference, but where I changed the subtraction to addition, I used green. And then when I had to change the second number to its opposite, I also used green so you could see what happened. So hopefully with that, those 3 problems, which is kind of like 6 problems, you got a better sense for how you're understanding. All right, so what do you observe? First of all, that subtraction can go to addition. And that the second number must go to the opposite. If it doesn't, you're going to end up with 2 completely different questions. So how is this helpful? I think it's helpful because you only then have to learn one set of rules. So you use and learn one set of rules. And that means we can just follow the rules that we've already known for addition, which here I'm just going to very quickly review. So how do we determine if the answer is going to be positive or negative? You look for the biggest absolute value. So what is our addition algorithm? Well, if we have same signs, we're going to add like normal. Those are kind of the easy ones. The less easier ones happen to be when we have different signs. Then you have to take the sign of the bigger absolute value, which we just covered, and then subtract out, because remember opposites, we're taking them away. This is also one reason why addition and subtraction go hand in hand. You subtract out the smaller absolute value. So I know that this video is a little more lengthy than some of the other ones, and it's because I wanted to combine both the chip model and the algorithm so that you would have those two to choose from. In class, we'll continue to practice on these, but if you have any questions or need a few more examples to help clear this up, please let me know in class so that you'll be prepared for the next quiz.